Today we are going to learn how to add and subtract two functions in differentiation. We will also prove this rule using first principles. Let's say that we have a function y equals f of x plus g of x. Here y is the addition of two functions f of x and g of x. According to the sum rule, the derivative of y, that is dy by dx, is equal to f prime x plus g prime x. This means that we can differentiate both functions separately and simply add them to give us the final derivative of y with respect to x. For example, if we have a function y equals sine 2x plus cos 3x, then the derivative of this function dy by dx will be equal to first the derivative of sine 2x, that is 2 into cos 2x, plus the derivative of cos 3x, that is minus 3 into sine 3x. This is our final answer. It's just simple as that, a one-line answer. So now we will look into the proof of this rule. So here we have a function y equals f of x plus g of x as our first equation. Our second equation will be y plus delta y equals f of x plus delta x plus g of x plus delta x, where delta x is an increment of x and delta y is an increment of y corresponding to delta x. Now you might be wondering all of a sudden, where did this delta y come from? We haven't been using this in our previous proofs. To understand this, have a look at our very first video in this chapter. Here we have delta y here. The delta y that we are referring here is this delta y. This delta y is an increment of y that is corresponding to this delta x, which is an increment of this x. So this is where we get the delta y from. Then our next step as usual is to subtract equation 1 from equation 2. So this will give us delta y equals f of x plus delta x plus g of x plus delta x minus f of x plus g of x. Now we rearrange this in such a way that the f functions are together and the g functions are together. There is a reason why we do this. You will notice this at the end of our proof. Then we divide both sides by delta x. So this gives us delta y over delta x equals f of x plus delta x minus f of x divided by delta x. So we bring all of this under one common denominator, delta x. And for the g functions, we have g of x plus delta x minus g of x divided by delta x. We bring this under one common denominator, delta x. Then we apply the limit for both sides. So this will be limit of delta y over delta x as delta x tends to 0 will be equal to, for the right hand side, we apply the limits for f functions and the g functions separately. So this will be limit of f of x plus delta x minus f of x divided by delta x as delta x tends to 0 plus limit of g of x plus delta x minus g of x divided by delta x as delta x tends to 0. So here this left hand side is equal to dy by dx, and here this part is equal to f prime x. If you remember, this is what we proved earlier in this chapter, and this part will be equal to g prime x. So this gives us our final answer. Dy by dx is equal to f prime x plus g prime x. So this proves our addition rule. So the difference rule is basically the same. The only difference is that we have a minus here instead of a plus. So here if we have a function y equals f of x minus g of x, the derivative of that function will be f prime x minus g prime x. You can try proving this on your own using the first principles. If you come across any problems, you can ask us in the comment section below. We also have plenty of exercises for you so that you can get used to this theorem in the description below. The answers are also given for your reference. So that's all for today's video. Until we meet again, take care.